Welcome to the deep dive. We're here to cut through the noise, get straight to the insights that really matter. Today, we're tackling something, well, frankly, it keeps a lot of us up at night. It's the challenge of hothouse Earth, driven by those ever increasing anthropogenic greenhouse gas emissions. And when you think about it, something like what, 84% of global CO2 emissions, they come straight from our energy systems or industrial activities. The scale just feels huge, almost, insurmountable. But what if I told you there's a surprising solution emerging? One that's not just optimistic, but actually economically beneficial. And it's already here, scaling up fast. So that's our mission for this deep dive. We're going to unpack how the really rapidly declining cost of solar photovoltaic PV electricity isn't just like a minor clean energy improvement. No, it's something much more fundamental. It seems to be a catalyst enabling a comprehensive, sustainable transformation of our entire energy industry system. We'll be exploring the I think, profound implications of a commentary paper. It's titled Low Cost Solar Power Enables a Sustainable Energy Industry System. This paper really zooms in on a specific techno-economic analysis by Lukes and colleagues, and for today, we'll just call that this study. Now, this study focuses on China, but honestly, its findings, they resonate globally. It
Right.
might just offer a blueprint for a sustainable future for, well, all of us. Okay, so let's unpack this. What I found most compelling, really the game-changing finding from this study is this. Their research indicates solar PV electricity is projected to be cheaper than China's current coal-based electricity. Just think about that for a second. For decades, right, clean energy was seen as, well, expensive, an ideal, maybe a luxury. But this analysis suggests it's fast becoming the cheapest practical option. For a huge part of the world's energy needs, it's really rewriting the economic playbook.
Yeah, and what's fascinating here is the sheer scale of the potential they're talking about. This study identified, get this, a technical potential of 99.2 petawatt hours. That's PWH for solar PV in China back in 2020. And it's projected to grow even more to maybe 146.1 PWH by 2060.
Wow, petawatt hours. That sounds astronomical. Can you put that in perspective?
It really is. I mean, that 99.2 PWH, it's enough energy to power, say, every single home in China for maybe 3 or 4 years,
Mm-hmm.
or fuel a city like New York for decades.
Mm.
It's just a colossal amount of clean power. It's several times larger than China's projected long-term total energy demand.
Okay.
And here's a really crucial bit. As of 2021, this study found that an impressive 78.2% of that 2020 potential had already reached price parity with coal power.
Already in 2021.
Yeah, already. And, we've seen coal prices climb even further since then, which just makes solar look even better, economically speaking.
So it's not just about the cheap electricity itself, then. You mentioned a catalytic effect earlier. What did you mean by that? Like, what other technologies does this cheap solar sort of unlock? And what does it mean for, how our grids might actually work?
Right, exactly. That steep cost drop for solar PV, it's not happening in a vacuum. It creates this cascade effect. It makes integrating other essential energy tech, like advanced battery storage, electrolyzers,
Yeah.
it makes them not just possible, but economically attractive.
Ah, okay. The storage and conversion piece.
Precisely. These are critical for a truly sustainable system, right?
Huh.
They let us store that intermittent solar power, maybe convert it into other energy forms when needed. So what this all leads to, and this is the fundamental conclusion of this study, is that PV battery systems, they're set to become a central pillar of China's power system. And it's not just because they're cheap. It's also their sustainability, their massive scalability, and the fact that solar resources are, spread out everywhere.
Right.
It really is a huge shift in energy economics.
And it sounds like this specific analysis, the Liu et al. One, this study is a pretty big deal in itself. You said it's one of the most detailed analyses to date. Documenting this competitiveness now and projecting it gets even better.
That's right. It provides a really granular look at the techno-economics. It shows this isn't just a blip. It's a foundational shift happening right now and likely accelerating.
Okay, but here's where I get a bit stuck. If the numbers are so compelling, why does it seem like solar PV's role, especially in a fast transition, has been so underestimated, even by, major institutions? It feels like maybe they didn't see it coming this quickly, or perhaps didn't quite grasp the full potential.
That's a really critical question. And I think part of it is just the sheer speed of the disruption, that cost reduction curve for solar PV, it's been exponential. It blew past the kind of linear projections many institutions traditionally rely on.
Right, it's hard to model that kind of drop.
Exactly. It's tough to predict something dropping 80–90% in cost within a decade. Plus, there's the inertia, of existing energy systems. and maybe some outdated assumptions about intermittency, about how hard it is to manage renewables. Many older models didn't fully bake in the rapid progress and cost drops in battery storage, for instance.
Ah, the enabling tech again?
Right, or the capability of smart grids to handle variable sources. So they often just didn't see the true systemic potential of solar combined with these other elements. And this study also brings up significant co-benefits, things often missed in standard energy analyses.
Like what?
Well, for instance, the huge cost savings from avoiding air pollution caused by coal. Think about public health improvements, fewer sick days, cleaner air in cities. That's immensely valuable, even if it's hard to put an exact dollar figure on it.
Sure, quality of life.
Definitely. And conversely, you've got the jobs created, the whole PV battery system, value chain manufacturing, installation, maintenance that creates substantial societal gains too. So all these benefits together, they really should push policymakers towards bolder, faster transition strategies, because ultimately a low-cost energy supply, that's the bedrock of international economic competitiveness, which really means starting from the early 2020s, the focus has to be on renewables and especially solar PV.
Okay, so this raises an important question then. Just how big could solar's share actually become? Are we talking like a nice addition or something really dominant?
Well, this study projects a solar PV share of 43.2% in China's power supply by 2060.
43%. That sounds really high.
It is. It's one of the highest values ever projected for China's power sector in any serious analysis. And actually, there's another study they mentioned that goes even higher, 70.5% by 2050, for a cost-optimized system.
Wow.
And it's not just China. Look at India. Because of its geography, even better solar resources, there's potential for an even higher share, maybe up to 89% in its power sector.
89%.
Potentially, yes. And even in Europe, farther north, less sun overall than China. Even there, studies project PV shares over 50%. In total, they found something like 34 publications across all continents projecting PV shares of at least 50% for sustainable energy systems by mid-century.
Okay, so this is definitely a global trend, not just specific to one country's analysis.
Absolutely. It underlines the global applicability and just the raw economic competitiveness of solar PV pretty much everywhere.
So if cheap solar is changing how we make electricity, the next logical step is thinking about how it reshapes the entire way we use energy across everything. It's not just lights anymore, is it? I mean, think about the ripple effect.
Yeah.
Manufacturing, transport, even farming. How does super cheap electricity redefine all that?
That's exactly the bigger picture connection we need to make. The move away from fossil fuels towards renewable electricity means those traditional combustion processes, they get substituted. Well, either by direct electric solutions where possible, think EVs, induction heating in industry, that sort of thing, or, and this is really fascinating, through indirect electricity use via what they call power-to-X processes.
Power to X. Okay, break that down a bit.
Sure. Power-to-X, or P2X, is basically using very cheap electricity, mostly solar, to create other things, other energy carriers or valuable products. So we're talking electricity-based fuels, e-fuels, e-chemicals, and critically important, green steel.
Right. I've heard about some of these, like green hydrogen for making steel, potentially phasing out coal in that industry. That's huge for emissions.
Massive. And then you have green methanol could become a major new bulk chemical, replacing fossil feedstocks in loads of processes. Green ammonia, too vital for fertilizers and agriculture, swapping out fossil-based ammonia, but it also has potential energy uses.
Okay.
And of course, e-fuels for ships and planes, essential for decarbonizing long-haul transport, which is really hard to electrify directly.
And the common thread is they all need that cheap, sustainable electricity to make green hydrogen first. Is that the idea?
That's the linchpin. Almost all these P2X routes start with producing green hydrogen using electrolysis powered by renewables. And that step has to be low cost and sustainable for the whole process to work economically and environmentally.
Got it.
And that's exactly where solar PV comes in. It emerges as the primary electricity source for these power-to-X processes in most parts of the world. Here's a really compelling example from the paper. Green ammonia. If you make it using hybrid PV wind power plants,
Yeah.
it's already cheaper than making it from fossil methane or coal today.
Really already cheaper.
Yes. Cleaner, greener, and lower cost.
Right now.
And that's a strong indicator that other e-fuels, other e-chemicals are going to follow the same path pretty soon in the near to midterm as renewable costs keep falling. So it becomes crystal clear. Solar PV isn't just disrupting the power sector. It's set to disrupt the entire energy industry system as we know it, changing how we make and use almost everything.
Okay, this sounds incredible, almost revolutionary. But it also points to a pretty massive challenge, doesn't it? Scaling up. I mean, you mentioned the numbers earlier. Going from around 138 gigawatt peak installed in 2020 to over a terawatt peak per year by the end of this decade, and then maybe 3 terawatts a year in the 2030s.
Right.
That's an enormous ramp up in manufacturing very fast. What does that actually involve beyond just, building more factories?
It is a significant scaling challenge. You're absolutely right. And it's more than just factory floor space. It requires transforming supply chains.
Yeah.
But the analysis suggests multi-Tdal-Bute annual manufacturing is achievable.
Mm.
To avoid bottlenecks, though, some adjustments are definitely needed.
Such as?
Well, things like switching materials. Moving from using relatively scarce silver for contacts in solar cells to more abundant copper, for example. That eases material constraints.
Okay, makes sense.
It also means getting serious about the circular economy. Really high standards for recycling, making sure old panels become resources, not waste.
Right, closing the loop.
Exactly. And, importantly, we need a rapid scaling of the glass industry, too. It's a key component. This study confirms that this kind of optimized industrial scaling looks achievable if we maintain annual manufacturing growth around 25% to 30% per year through the 2020s and early 30s.
25–30% growth year on year for a decade or more.
It's ambitious, no doubt, but the analysis suggests it's within reach.
And just when I thought the vision couldn't get any bigger, this study brings up something else. Solar PV enabling net negative CO2 emissions. Going beyond just cutting emissions to actually pulling CO2 out of the air.
That does sound a bit like science fiction territory, doesn't it?
It might sound that way, but the technology is real and it's becoming scalable. It's called direct air capture with carbon storage, or DACCS. And it can function as a scalable, relatively low-cost way to achieve net negative emissions. And crucially, it can be powered entirely by solar PV electricity.
So, like giant solar-powered vacuum cleaners for CO2. Sort of. Think of DCAC units as big modules that chemically pull CO2 straight from the ambient air. And like solar panels and batteries, these DAC units are highly modular. You can build them in different sizes, scale them up easily.
Okay.
And because they're modular, they tend to follow similar cost reduction curves, learning curves, just like solar panels did, so they get cheaper as we build more.
Right. The economics improve with scale.
Precisely, making it increasingly attractive economically to just capture CO2 directly from the atmosphere. And here's the really remarkable estimate from this study related to this. They calculate that we wouldn't need to add more than about 10% on top of the planned global PV capacity we already need for energy and industry.
Just 10% extra solar.
Around that, yes. Just 10% more PV capacity dedicated to powering these PV-based DACCS facilities could be enough to rebalance atmospheric CO2 back down to 350 parts per million by the end of this century.
350 ppm, that's the level many scientists say we need for a stable climate.
Exactly. It offers a clear, potentially economically viable pathway to stabilize global temperature at 1.5 degrees C, maybe even below, fully meeting the Paris Agreement goals. It's a powerful idea, isn't it? That solar could not only power our future cleanly, but also actively help clean up the emissions from our past.
Wow, what a deep dive this has been. The insights from that paper, low-cost solar power enables a sustainable energy industry system, are truly profound. This commentary really underscores how rapidly falling solar PV costs are set to do so much more than just generate electricity. It seems like they're poised to disrupt the power sector completely, become a major primary energy source across the whole system, enable sustainable chemical feedstocks, and even provide these scalable solutions for net negative CO2 emissions, potentially fulfilling the 1.5 degrees C Paris target.
Absolutely. And while these findings are incredibly powerful for a country like China, given its size and economic influence, they arguably hold even greater promise for countries in the global south.
Why is that?
Well, often stronger solar resources, sometimes more land availability, and rapidly growing energy demand. The economics could be even more favorable. It really does offer a potential blueprint for a sustainable energy transition everywhere, driven as much by economics as by environmental needs.
So for you, our listener, just consider the huge implications of these projections. For policy, for investment, for industrial planning. If this analysis holds true, what new industries might pop up? Which existing ones will face radical transformation in this coming solar-powered future? It's a future that, it seems, we're all building right now, one way or another. And maybe, just maybe, it looks a lot more optimistic than many of us thought possible.